Next, 46. Symbols used in equation together with the explanation of the symbol are shown below. Which is correct? G for grams, L for liters, aqueous for dissolved in water. Something we dissolve in water, we will call it as aqueous solution, AQ. And S for solids. Okay, symbols used in equation together with the see, for G is not for grams, okay, G for gaseous state, G for gaseous state. And see, in a chemical equation, we are not supposed to use grams, right? Okay, if it is solid, we mention S. So, if it is solid, we mention S as a subscript. And if the something is dissolved in aqueous medium, water, if something is dissolved in water, we call it as aqueous solution, we write aqueous. Okay, and these two are correct. See, and in chemical equation we doesn't need to mention liters or grams, such thing, right? If it is in liquid state, if something is in liquid state, we will write L. So L for liquid, not for liters. G for gaseous state, not for grams. So C and D are our options. In chemical equation, H2O2 gives rise to H2O plus O2. The O2 is a product. O2 is product. O2 is not solid. It is not reactant. It is not catalyst. It is the product. Yes. Which of the following is correct skeleton equation for the reaction that takes place when solid phosphorus combines with oxygen to give diphosphorus pentoxide, P2O5. That means phosphorus plus oxygen gives rise to P2O5. Okay. Solid phosphorus combines with oxygen gas to give diphosphorus pentoxide. So phosphorus solid, oxygen gas, it is not pentoxide, diphosphorus pentoxide. Solid phosphorus, O atom is given, O2 is not given, that's why it is wrong, and P5O2 is wrong. Diphosphorus pentoxide means P2O5. Solid phosphorus, oxygen, O2 gas, P2O5. So that is the best option. See, solid phosphorus mentioned correctly. Oxygen is O2, it is in gaseous state, mentioned correctly. And phosphorus pentoxide, P2O5, solid. Okay? Yes. Next, question number 49. Which of the following statement is not true about what happens in a chemical reaction? Okay? The way in which atoms are joined together are changed. Yes. Okay, that is happening in a chemical reaction. That is shown. Which of the following statement is not true about what happens in a chemical reaction? In a chemical reaction, we can understand the way in which atoms are joined together and changing their bonding. Yes, that is correct. New atoms are formed as products. See, in a chemical reaction, new atom is not created, not formed, only atoms rearranges. Atoms change their bondings. Old bonds are breaking, new bonds are forming between the same existing atoms. So the starting substance are called reactants. That is correct. A is correct. The bonds of reactants are broken and new bonds. See what I told you. The bonds of reactants are broken and new bonds of the products are formed. So A, C, D are correct. We need to found not true. So B is not true. Our answer is B. Question number 50. In a combustion reaction, one of the reactant is, in a combustion reaction, one of the reactant is definitely oxygen. If you want to burn something, that means if you want to combust this methane gas, you have to supply oxygen. Okay, so whatever you want to burn it, you have to react that with oxygen. So reaction with oxygen can be called as combustion. In combustion reaction, one of the reactant is oxygen. The type of reaction that takes place when one element reacts with compound to form a new compound and a different element. Combination, displace, combination, decomposition, single replacement, single. See, type of reaction that one element reacts with compound to form new compounds. See, simply, if you take copper and treat with silver nitrate, you will get copper nitrate, unbalanced reaction I am writing, and silver. Here one element reacting with a compound to give new compound and another element, different elements. It's a single displacement, single replacement. Yes, it's not combination, it's not decomposition, it's not double displacement. Only copper displaced silver. Next, in a double replacement reaction, the products always molecular. Yes. Reactants are two ionic compounds. So it is not compulsory. Reactants are not, see, in double displacement, reactants are not supposed to be ionic always. Okay, only the two counterparts has to be interchanged. Reactants are two elements. No, two compounds interchanged their counterparts to give two new compounds. Okay, the products are new element. No element in the products. So the best products are always molecular, the best option. Okay, yes. What are the correct formulas and coefficients for the products of the following double displacement? RbOH, H3PO4. So the cation of rubidium has to interchange with anion phosphate, and hydrogen and oxygen, H plus from acid combines with OH minus from base. See, rubidium hydroxide is the base we are taking, Rb plus OH minus, and H3PO4. So actually, if you want to understand what happening, which ions are interchanging here, you have to break down into ions, okay, in your imagination. Rb plus OH minus, H plus, actually 3H plus, and PO4 3 minus. Okay, now try to interchange the counterparts, like Rb plus combines with phosphate. So Rb is having only 1 plus, it is having 3 minus. That means for one phosphate you need 3 rubidium ions. That's why I'll take 3 here. Okay, so what happens? Rb3PO4, rubidium phosphate. Okay, and that 3H plus. So when you take 3 rubidium hydroxide, 3 OH minus are formed. Okay, 3 Rb plus, 3 OH minus. 3 OH minus combines with 3H plus to give 3H2O. Okay, Rb3PO4 3H2O, Rb3PO4 3H2O, correct. Okay, C option. Next, question number 54. Which of the following statement is not true about the decomposition of simple binary compound? Not true. The products are unpredictable. No, we can predict the products, because in a decomposition reaction, the compound breaks down into simpler compounds. The simpler compounds or elements coming are from this compound only. We can predict what kind of products or what products are coming. So this is wrong. Check the rest of the option. The products are the constituent elements. Yes. The reactant is a single substance. Yes. One compound breaking down into simple compounds. Yes. The reactant could be ionic or molecular compound. Okay. That can be ionic compound or molecular compound. Yes. These three are correct. First option wrong. So we need to find which is not true. So our answer is first option. 55. Which of the following statement is not true about double displacement? Products may precipitate from solution. Yes, that is correct. The products may be gas. Yes, product can be gas. The product may be molecular compound. Yes, the reactant may be solid metal. The reactant may be solid metal. No, in double displacement, see, if one of the reactant is copper and another is NO3 minus, so it comes under single displacement. So reactant may be solid metal. No. For it to be double displacement on both we have to take compounds. Okay, now Na plus exchange with NO3 minus and Ag plus with, so then only it will be double displacement. Okay, not true is this one. 56. In a double displacement reaction or double replacement reaction, the reactants are usually metal and non-metal. The reactants are usually metal and non-metal. In double displacement, no. Same, in a double displacement, the reactants are always like this only. Okay. So that is wrong. One of the reactant often water. No. It's not hydrolysis. The reactants are generally two ionic compounds in aqueous solution. Yes, generally. Just like NaCl aqueous plus AgNO3 aqueous. Okay, this cation exchanges with this anion, this cation exchanges with this anion, you will get AgCl solid precipitate and NaNO3 aqueous. Okay, energy is in the form of heat or light is often produced. Yes, energy is often produced. The best. The first one is wrong. The reactants are usually metal or non-metal. No. They are compounds. They are binary compounds in general. The equation H3PO4 plus 3KOH gives K3PO4 plus 3H2O is an example of, it's a displacement neutralization. Yes, double displacement. Okay, H plus and OH minus displaced, K plus and phosphate displaced, double displacement. Yes. The equation C3H2OH plus 9O2, I think something is missing here, plus symbol, 9O2 gives rise to CO2 is an example for which it's a combustion. Organic compound when treated with oxygen to give, okay, some organic compound like C2H5OH, some organic compound, you are treating that with oxygen, it's a combustion reaction. The reaction of iron and chlorine to give FeCl3 is an example of two elements combined to give compound. It's a combination type. Combustion, combination type. The equation Mg plus HCl gives MgCl2 plus H2 is an example of combination, single, single displacement. That is correct because element HCl gives rise to MgCl2 plus H2. I explained this in reactivity of metal concept. That means here magnesium is liberating hydrogen gas from HCl. So magnesium reactivity is such that it can liberate hydrogen gas from acid. It's a single displacement, single replacement. Fe2O3 plus 2Al gives rise to Al2O3 and Fe. Let's see what type of reaction this is. Here aluminium displaced iron from iron oxide to give aluminium oxide. Aluminium just thrown out iron from this iron oxide. Okay, just 2Fe displaced, right? It's a displacement reaction. Next. Which of the following is not a chemical change? Melting of ice. Melting of ice is not a, see, when ice heated, you will get water. The point is in both cases, it is H2O only. No, chemically not different, only physical state changed. So melting of ice is not a chemical change. Carbon cycle is a chemical change. Dehydration of substances. Dehydration means water is coming out from some substance. There is a chemical change. Fermentation is a chemical change. Melting of ice is not a chemical change. The symbol of H stands for dash of hydrogen. It's just one atom. See, when there is H, it is one atom. H2 means hydrogen molecule, one atom. Okay. Okay, I hope you understand. If you have any doubts, don't hesitate to reach us. Thank you very much. I'll meet you with the next concept.